Hello! Welcome back to Chem 121. I hope everybody enjoyed their weekend and had some time to both get some work done and relax, because we are back at it again today. So on the screen at the bottom, you could see the announcements for the day. Those are up the entire period, so make sure that you see those things, because if you email me about them, I'll be like, why didn't you look at the announcement? Quiz number 1 is due yesterday. Tonight is last call. You'll get an email about that at about 6 p.m. or whatever time I set it for. Excuse me. Just reminding you that, like, hey, you have to turn this in by 11:59 or you don't get to turn it in at all. So make sure you get that in by the deadline. Lab worksheet number 1, I sent out another announcement to extend the deadline for that one by a day, because some of the stuff that we're going to be doing today is a little bit helpful in answering the questions, particularly the later ones. So that'll be due tomorrow, 19 January, instead of 18 January, which was what is said in the syllabus. The other thing I want to mention is that all weekend I've been getting emails from people who didn't know how to access the lab stuff. So what I'm going to do here is I'm going to capture... Is it this one? Yeah, it's this one. There we go. So we'll put this on the screen here. So I am in our 121 page. Mine looks a little bit different because this is my global one, and I push updates out to other people. If you scroll down to the labs and stuff, the first thing you will see up here is how to upload completed worksheets to Canvas. And this document will tell you everything you need to know, not just about uploading stuff, but downloading it. I realize that I probably need to rename that document so that it is a little bit more transparent on what it contains. But it tells you, first thing you need to do, download both the files. So that would be these two files here for lab number 1. Every time you do a lab, download the worksheet and open the Google Sheet. If you are trying to do stuff without the PDF, you're not going to be able to do it, because I don't put everything in the Google Sheet. Otherwise, it'd just be too big. Why would I make 2, right? So the lab worksheet PDF tells you what to do for the assignment, and then the Google Sheet is where you enter your information. And then it shows you how to get your own copy here. So it is in read-only mode, which means that you cannot enter data into it, because everybody has access to that file. If you start typing in your data and somebody downloads the file at that moment, they get all your data. I obviously don't want that. So you have to download your own copy following these directions. I showed you how to do that in the lecture video last week to make a copy. What I didn't show you was how to submit your file into Canvas. And so what you're going to do is, once you've made a copy and are working on this on Google on your own, at the end you are going to go to File, Download, and you're going to download the file as Microsoft Excel.xlsx. If you download it as any other file type, it will not upload into Canvas, because I have required it to only accept Microsoft Excel files. Okay. The reason being, that's what I have here at home, and that's how I will open your files to grade your assignment. Very, very, very important. And I'm not sure if this is actually mentioned here, but Canvas does not know how to interpret what an Excel sheet is. So when you upload it to Canvas, it's going to look like complete garbage. And all the formatting is going to break, and it's going to look like half of your information is missing. That is okay. Do not worry. Okay? The only thing that you should do once you have downloaded your file is upload it to Canvas. Do not open the file. Do not edit the file. Do not save the file. Okay? Once you have downloaded a copy and it is all self-contained, don't open it with any other program other than Google Sheets. There are sometimes issues where if you open something in another program and then I get it and I can't open it, that I will email you back and say, this is an invalid file. Send me another copy in 24 hours that functions, or get a 0. And if you're in that situation because you decided to do everything on like Microsoft Excel Online, I can't help you. Okay, so please use Google Sheets, download it as a Microsoft XLSX file, upload it to Canvas, and then I will grade it for you. Okay? So I apologize if that wasn't as clear as it could have been earlier on. But that's the gist of how we do lab worksheets in this class. And again, that is due on Wednesday. Due Wednesday, and you have 24 hours after that, so you could turn it in as late as Thursday. I want to say that we had these 3 problems, and I had you working on them, and then we ran out of time. So I'm going to start by working on the solutions for these. All right. Now, the way that I'm going to do these is going to be the way that I recommend to you, to solve all of these problems, which is you write out all the units every single time, okay? Very critical, because later on when we get to things that are more confusing in terms of how many units are present, if we neglect units, it will get very difficult to determine what is going on. So do not just write a bunch of numbers. I know that the habit of a lot of introductory students to math and stuff is, I don't want to write all the units. The units don't mean anything. Well, they mean a lot, actually. 100 meters is very different than 100 miles, right? And if you just put M for both, because they both start with M, you're going to get confused when you go back and look at it later. Or, more importantly, if you show it to somebody to convey that you know that information. So be really cognizant of what the units are, because if you can set up the units so that they cancel, then you win. All of the numbers will work out. Spoiler, 95% of math that involves units, you could solve it by just setting up the units in a way that they cancel. I got through college this way. Just like shit, I don't know what I'm doing. What was the formula? I'll just cancel out units. They want pressure, right? Well, pressure is this. And you get the right answer, believe it or not. So you can actually do a lot with units. So we have 2 liters of soda. And I want my answer to be in centiliters. So I got to get rid of liters somehow and turn it into centiliters. So I want to do something like this, right? I just need to convert liters to something else and fill in the space right here. Well, if I go back and look at the metric slides, which if we do this, we could just go whoop. There we go. And I can see that, well, oops. Well, I don't see it if I do that. I can see that centi is 10 to the minus 2 of the thing that I'm looking at. So that could be centimeter or centiliter or centi whatever. Any unit that I want to stick after centi will work for this problem. So that's what we're going to do. That's the wrong slide, Wes. Where are we? We are right here. There we go. So I'm going to copy down that conversion. 1 centiliter is 10 to the minus 2 of the thing that we're looking at. We're looking at liters, right? So there you go. Now I can just put the units in the blank right here, because I'm going to convert liters to centiliters. And now I can just match up the numbers. So 1 centiliter, 10 to the minus 2 liters. And when you punch this in your calculator, you should get 200. If you don't, and you get like 0.02 or something, the issue is down here. You got to put parentheses when you're typing it in your calculator. Okay, so be mindful of that. If you're typing in a number and it doesn't work like you expect it to, like, oh, I should have centiliters, it should be a bigger number, and you get a smaller number, check for parentheses, especially when dividing. Can we do a conversion of Fahrenheit to Celsius? I think that might be coming up in the slides, actually. Hold on. Yeah, we're going to do that later today. So we'll get to that when I get there. Crap, I got to find it again. There we go. That's not right. That's right. There we go. Yeah, we got to just get to that part because we have so much still to do. Let me put this right here. Can I show an example of what I put in the calculator? This is where I wish I had my TI emulator set up. I meant to do that, but I completely forgot. So what I can do is I can do this. So if you don't have a calculator handy, what you can do is have this really teeny tiny web page, apparently. So that's not what I want at all. I want... There we go. So this is Wolfram Alpha. And what Wolfram Alpha does is it's an online calculator. And so what I would type is something like this. So I wanted to type in that 2 times 1 divided by 10 to the minus 2. So here's how I do that. I would put all the numbers on the top. So 2 times 1. And then divided by, parentheses, all the numbers on the bottom. 10 to the negative 2. And then I hit equal, and I hit enter. And I should get 200, and a crying cat. Kresnik, stop! And so when I scroll down, it tells me the answer. Okay. So if you have never used an online calculator, Wolfram Alpha is actually very good at that. I'm going to just go like this and copy the link and put it in the chat for you. There you go. But that's how I would type it in the calculator, with abundant parentheses. I have a cat that is crying because he is bored. So I apologize if I get distracted by that momentarily. All right, so for the next problem here, where'd my pen go? There it is. I have 175.3 kilograms. Apparently we're in blue now, so there you go. And I want the mass in milligrams. So going back to my conversion, Kresnik, stop, dude. He's trying to jump in my lap now. Now he's going to run away and barf because I tried to pick him up. Because my cat is anxiety personified. All right. So if I go back to the this sheet right here, let's find this. So if we go back here and we look at our metric table, you'll notice that I have a kilo line, which is right here, and a milli line, which is right here. Now, all of these are relative to the base unit that we're working with, which is, in this instance, meters, because that's what the problem is asking, right? Or not meters, I'm sorry, grams. I have kilograms and milligrams. But what's important to note here is that this table does not allow you to go from one directly to the other. I can't do that. What I have to do is I have to do something like this. I can turn kilograms into grams back and forth, right? Using 10 to the 3. And then I can turn grams into milligrams back and forth using 10 to the 3. 10 to the minus 3, actually. So what I really need to do is I need to turn kilograms into grams and then grams into milligrams. So this would take 2 steps and have us do 2 calculations. So that's what we're going to do in our sample problem here. So let's do that. So I have, well, right over here, 1 kilogram is 10 to the 3 grams. And 1 milligram is 10 to the minus 3 grams. And that should be a G up there. All right, so now that we have those conversion factors, let's just put the units in here. So kilograms to grams. So those cancel out. And then I'll fill in the numbers, right? 1 kilogram was 10 to the 3 grams. And when I do that, I get this. So now our answer is in grams. But the problem is asking us, well, I don't want grams, I want milligrams. You can see up there, what is this mass in milligrams? So we'll just do this again. So we'll cancel out the units so I get the units that I want to. And then we'll fill in the numbers again. 1 milligram is equal to 10 to the minus 3 grams. And when you punch that in the calculator, oops, my 3 disappeared. You get an even bigger number, or... Wow, it's not liking 3s for some reason. 3, 4, 5, 6, 7, 8. If you like scientific notation, there's your answer. So the first step that I did was to turn kilograms to grams. The second step is grams to milligrams. Can you do it in one step? No, you may not. You have to do 2 conversions. Now, what you can do is instead of doing one conversion, getting the answer, and then putting it over here, and then doing the second conversion, instead, you could do both conversions at once. Because that's how multiplication works, right? I keep writing a decimal point when I don't mean to. So I could turn kilograms into grams, and then put in the numbers. And then I could just turn grams into milligrams. And I'll put those numbers in too. And then I'm just doing, so this part right here, this first 2 that I multiply together, I should get this answer that I got up there, right? And then I'm taking that answer and multiplying it by the next term. So as long as I line up all my units in a row like that, and I do all the multiplication in a line, or on train tracks, or what have you, you'll get the right answer. So when I punch all of this in the calculator, I still get the same thing. So it's kind of up to you. Do you want to do the problem stepwise, because that's easier for you to think in one-step chunks at a time? Okay, I got kilograms to grams. Now I have an answer in grams. What do I do with it? I can turn grams into milligrams. And there you go, you get the answer. If that helps you, go ahead and do that. Otherwise, if you want to just set it all up in a line, that works too. Whatever gets you to the end, right? All right, there are questions. Let me answer these. So you can answer with either whole number or scientific notation whenever the directions are not specified. Oh, I'm going to sneeze. Hold on. Sorry, I'm fumbling around trying to find mute before I actually sneeze here. So if there are no specifics given, you can type your answer in either standard or scientific notation on either Canvas or the worksheet or whatever. I don't require it. The exception to that is if you need to use scientific notation to get the correct number of Sig Figs. And so, again, an example of that would be something like, I need to do 3,200, but I need 3 Sig Figs. And so the only way to do this to get these 3 to be significant is to write it like this. Okay? So just be mindful of that. All right, that was an aside, so I'm going to just put a scribble through it. All right. It takes 418,400 centijoules of heat, of energy, to heat a sample of water to a higher temperature. How much energy is this in kilojoules? What the heck is a joule? A joule is a unit of heat. In fact, a joule is analogous to a unit that you're probably familiar with called the calorie. When you eat, you gain energy, right? That's why we eat. We don't eat because it tastes good. I mean, that's why I eat, but that's not why my body demands sustenance. We demand food because it contains energy. And energy is used to heat us up. Literally, we burn the glucose by oxidizing it, and we turn it into CO2 and water. And we produce energy that allows us to make ATP and do all sorts of crazy biochemistry. Now, the joule is the physics unit of that sort of energy. And so we're going to write down, we'll do this in black again, just to separate out the problems here. So 418,400 centijoules. And I want kilojoules. Well, we've already covered today that 1 centi anything is 10 to the minus 2 of that thing. In fact, we did that up here, right? There it is right there. That was with liters. So all I need to do is just do this. It does not matter what unit you're using. These prefixes will function regardless, because that's the beauty of the metric system. So I could just cancel these out and then fill in the numbers. 1 centijoule, 10 to the minus 2. We also know that 1 kilo whatever, in this case joule, is 10 to the 3 whatever. Up here we did we did that with grams. So there's kilograms to grams. So there's my conversion. Uh-oh, Windows is yelling at me. No, I will not update in the middle of my lecture. Kilo is universal, so whether it's grams, meters, or joules, it's the same conversion. So I will just do that right here. So joules, kilojoules. Set up the units so they cancel out. And then fill in the numbers. 1 kilojoule, 10 to the 3 joules. And now I can just punch all this in the calculator. Again, use parentheses, so I'll put parentheses around the top and the bottom here. And my calculator has a pair of scissors on it because that's safe. That's where I store my scissors, on top of the calculator, apparently. So 418,400 times 10 to the minus 2 times 1 divided by 1 times 10 to the 3. And I get 4.184 kilojoules. Which, believe it or not, I've actually specifically chosen this. Is it exactly 1 calorie? Now, you do not need to know this. This is just trivia out here. The objective of the lesson is for you to be able to convert units back and forth. And that's what we're going to be doing pretty much all day today. All right. If you have any questions, let me know. In the next section, what we're going to do here is we are going to be converting to non-metric stuff. So for metric, you have this table that you can refer to all the time. You can just use it however you want to. Again, remember, you can only go stepwise back to the base unit and then to some other unit. So if I wanted to convert any 2 of these from one to the other, I have to go through whatever the base unit is, whether that's meters or liters or kilometers or moles or whatever. If you are using a different unit that is not metric, in your textbook is a table that says Table 2.2 and has these conversions on there. Now, if you don't have your textbook for whatever reason, like it hasn't arrived yet or whatever, use Google for this. So what we're going to do is we're going to take this orc here, and instead of going from kilograms to, say, grams or milligrams or megagrams or micrograms or whatever, I'm going to go to pounds. In the metric table, why are some red and some black? So in in-person versions of this class, I make you memorize the red ones. The black ones are used in chemistry, and actually stuff does go in these spaces here. I just have erased it for this class because they're uncommon. In this specific class, because it's online, you can use any notes for any assessment at all. You don't have to worry about memorizing anything. I mean, you should, but you probably will memorize it just by virtue of using these so often. And that's fine, as far as I'm concerned. For this problem, we are going to convert 150 kilograms to a different unit of weight, which is pounds. And so we need to look up a relationship between kilograms and pounds, and some number of each is going to be our conversion here. Now, if you have table 2.2 available, you could flip to that, and you can look up the conversion on there. Alternatively, since you probably have a computer, which is how you'd be watching this, I assume, you could instead go to Google. And we'll do that. We can cover up my face, that's fine. And so it says here that 1 kilogram is 2.20462 pounds. You use as many Sig Figs as you need. I'm going to just pick 4 because that's kind of the standard that I do. So we'll get rid of that. And so that was, again, 1 kilogram, 2.205 pounds. So now I have my conversion, and I can use this number right here as my starting number. And I can do the conversion. I don't want kilograms, so we'll put this on the bottom to cancel it. And we'll convert to pounds, and then we'll fill in the numbers. So that, again, 1 kilogram, 2.205 pounds. And the number I get when I do that, it looks like it's going to be 330. 330.75 pounds. There's my answer. Now, we need to worry about Sig Figs. How many Sig Figs does each number have? This number is written, the 1 and the 5 are significant, but the 0 is a placeholder. So this is 2 Sig Figs. How many Sig Figs is this? There are 4 digits that are either not 0 or a trapped 0, so this is 4 Sig Figs. And then this down here, whenever you see 1 by itself, we're going to work on the assumption that that is exact. And that you can ignore Sig Figs for any 1s by themselves. The reason being is because if you have just a 1 and you treat it to 1 Sig Fig, all of your answers are going to become 1 Sig Fig. So anytime you see a digit by itself, or a times 10 to the, or whatever, you can just ignore that for Sig Figs. Okay, so my answer here is going to have 2 Sig Figs, because I'm multiplying and that's the lowest. So I would report 330 without a dot pounds. My OBS is blinking, and I don't know why that is, but everything seems to be working. Okay. All right. Now what I'm going to do is I'm going to do this, and you're going to go, what? Why are you doing this? Whoops, everything is gone. Now, why didn't I clear all the ink? Because it's actually faster for me to do it this way. What I'm going to do is we're going to go back to Google. Let me get window 5 open again. There we go. And what I'm going to do is this. Well, wait a second. I looked up the conversion and I got these numbers. See what I did there? I put the 1 on the other side. Because in 1 pound there's this many, or in 1 kilogram there's this many pounds, right? But in 1 pound there's this many kilograms. Those are different numbers, aren't they? What will happen if I use that set of numbers there? So let's write that down. 0.4536 kg to 1 pound. I saw your question there. I'll get back to that in just a second. What if I use this conversion? What will happen? Will I get a different answer? And the answer is no. It turns out you get the same answer because the units will still cancel out like before. So I'm going to have an answer in pounds. And I'm going to put my numbers in different spots here. I notice there's a decimal point here. I want to get rid of this. There we go. Or a stray mark or something like that. 1 pound is 0.4536 kilograms. And when you punch that in the calculator, 150 divided by 0.4536, believe it or not, you get the same answer. It's slightly different. This time I got 330.687. But this still has 2 Sig Figs. And so I still report it to 2 Sig Figs. And I get the same answer. What is the benefit of... I can't read it because it's small on my capture. Let me get the chat up here. What is the benefit of making 150 kilograms to 2 Sig Figs? There is no benefit. It is required. That is the number of Sig Figs 150 as written has. If I wanted 3 Sig Figs, I would have to have written this. 150 kilograms. And if I wanted 1 Sig Fig, I would have rounded to 200. So... that's just how we numbers. That's how we do these. All right. I have shown you how to do a conversion by using any conversion you can find. So you aren't restricted to metric. You can use any conversion that you want. So my slides will just go through that here. If you were to convert 4 tons of something into grams, would the final answer have only 1 Sig Fig? So if the number given to you was 4 tons, then yes. If it was 4.0 tons, you'd have 2 Sig Figs. If it was 4.000 tons, you'd have 4, and so on. So the number you start with matters. Now, other conversions that are being used also matter, but in almost every case, the number you start with is going to be the one that determines how many Sig Figs are in your answer. So that's just a good practice to get into. How many Sig Figs does the number I started with have? I'll just use that many or more on all my conversions, and then I don't have to worry about it. All right, I have 3 more problems for you to try. I'm going to give you about 5 or 6 minutes to work your way through these. So I used to own a Harley-Davidson 2006 Sportster. In September, I gave it to charity because I moved to this apartment and there's no garage here. And I didn't want to just sit out in the rain. So I donated it. But when I had a Harley, it weighed 579 pounds. What would that mass be in kilograms? Use dimensional analysis like I showed you to convert that. Back when we had... this second problem is obsolete for multiple reasons. Back when I had a Harley and back when I traveled to work on my Harley, I traveled 15.5 miles. How many kilometers is that? And then finally, a soda bottle contains 2 liters of soda. How many gallons is that? Now, you're going to have to look up a conversion for liters to gallons there. Use Google or Table 2.2 if that's there. I'm going to console this cat because he is just like... this is the 3rd time he's come up to me. I think he might have just broken the water bowl or something, so I'm going to go check on that. I'll check back with you in just a little bit. Type your answers in the chat once you get them. I will number these for you, so we'll say 1, 2, 3. We'll go over the answers together in just a bit. See you soon. All right, 1 or 2 more minutes, and we'll go over the answers together. Oh, the other cat is here. Maya, do you want to say hi? Hold on. Say hi. Very good. I hope everybody heard that. Good. Now, can you leave me alone? I gotta teach. You can sit on your pillow. Sit on your pillow. Yeah, sit on your pillow. Maya has her own pillow next to the computer. Because that's the kind of cat dad I am, I guess. I don't know. All right, let me minimize this. We'll go over the answers here. So we'll get the first problem on the screen. All right, so we'll scroll back up to the top here. So we have space to work. And here we go. Okay, so I'm going to look up the conversions in Google that I'm going to be using, and then I'll just write them in the problem so that we can save some time here. So my motorcycle weighs 579 pounds. I need to turn pounds. Ooh, I don't know what I did there. There we go. Into kilograms by doing this. And then I have to go look up a conversion on Google from pounds to kilograms. And so I'm going to use the first one that we had because that's what was on my screen still, which was 1 kilogram is 2.205 pounds. So if I take 579 divided by 2.205, I get 262.58, which for 3 Sig Figs would be 263 kg. And then to check Sig Figs again, so this is 3 Sig Figs, this is 4. And then this we ignore. 3 is the lowest, so my answer should have 3 Sig Figs. All right. Let's look at problem 2. I travel 15.5 miles to work. And it's actually really nice when you live relatively close to where you work. Like, I didn't mind my commute at all when I did it. Now, however, that my commute is about 15 feet from bed to the computer, I have to go to a different room. It's kind of nice. I don't know how I feel about going back to work in the spring. All right, so if I go miles to kilometers on Google, it tells me that I have a, well, so first we'll put the units up so that I can cancel them out and get the units I want. And that says 1 mile, 1.609 not kilograms, but kilometers here. There you go. And so if I multiply those together, 15.5 times 1.609, I get 24.9395 km, which 3 Sig Figs, 24.9 km. Why is it 3 Sig Figs? Because this is 3 Sig Figs, this is 4, and this we ignore. This is the lowest, so our answer here should have 3 sig figs. All right, and then the last one, a bottle contains 2 liters of soda. How much is this in gallons? So we can go 2 liters. And a conversion from liters to gallons likely exists on Google because, I don't know, maybe you live in Canada and you want to know, oh, how many of our liters are in one of their gallons for, say, gasoline? And according to Google, I have here that 1 gallon is equal to 3.785 liters. And so when I multiply these together, we'll divide actually. 2 times 1 divided by 3.785, I get 0.52840 gallons. And for this one, since there's a question about sig figs, we're going to do the sig figs together here. How many sig figs are in this first number? It's just 1 digit, right? We ignore ones by themselves. And then this has 4 sig figs. So what's the smallest number of sig figs? Because we're multiplying, there we go. So my answer should have only 1 sig fig. And so I would actually report this as half a gallon because there should only be 1 sig fig in our answer. So if you are given a number of sig figs, your conversion should have that many sig figs at least, or more. You'll notice that I'm using 4 sig figs for all of these because it's ingrained in my head that that's how many I usually will need. But if I gave you a number that had 5 sig figs and then you used a multiplication factor that only had 4 in it, then your answer would get reduced to 4. Because, again, the smallest number of sig figs in the multiplication problem that you're doing dictates your answer. So, therefore, you want to use as many as is appropriate for a problem based on the information that is given to you. And so your starting number is always going to tell you most of the information. So up here, even though I had 4 sig figs on my calculation for the first problem, it's not going to really matter when I round to 3 sig figs. So if you want to see that in action, what you can do is you could just cross this out and turn this into a 1 and say, well, I'm going to do the problem again. 579 divided by 2.21. And when you do the problem, you get 262 as your answer. And they're like, well, wait a second, those are obviously different. But remember, the last digit's estimated. So, of course, they're going to be off by 1 or so in the last digit, right? Because that last digit is always an approximation. There's a difference in the conversion of table 2.2 in Google. Which one should we use? Use either one. You'll get an answer that's close enough to the correct answer. Did you mean you ignore the 1 as a sig fig because it's a 1 and not because it's a single number? That is correct, yeah. So if you see a 1 by itself, that is implied to mean exactly 1. If you see any other number by itself, though, treat it as a single sig fig. I'm going to answer that temperature question after the break when we get to temperature. So we'll talk about sig figs with temperature because that's a formula and that's kind of a special case. But we are at our break. So I'm going to put the break timer up here. Oops. Hold on, let me reset that. So we'll reconvene in 10 minutes, and when we come back, we're going to do even more conversions that are more complex, that have unusual or weird conversion factors. So we'll see you for that. Until then, enjoy the dulcet sounds of Stardew Valley. Alright, we are back. Now, something that we've been doing as we do these dimensional analysis problems that we've been studying today is we've been doing them stepwise and just punching in the numbers for each thing and then going to the next step and then the next step and then the next step. Now, oops, sorry, the mic was a little farther away from my face than I intended. Now, sometimes it's very obvious what you need to do a conversion. Like, oh, I need to convert miles to feet. Sure, that's easy enough. Or, oh, I need to convert kilometers to meters to centimeters. But sometimes the end point is so far away that it gets difficult to try and like see where the goal is beyond the horizon. And so in that case, I have this suggestion for you, which I call the unit map. And what you're going to do is you're going to find the number that you're starting with, which is the value in the problem. So like in these previous problems that we had here, this would be the value that I was given. This would be the value I was given. This is the value I was given. There will always be a value, just a number by itself with a unit. That is not a conversion of some sort. And that's where you're going to start. And you're going to write down those units and make a little blueprint out of it. So, for example, if I wanted to go back and do this first problem here, pounds to kilograms, and I wanted to make a little map out of it. I lost my mouse. Where did it go? There we go. The cursor, not the device attached to the computer here. So, if I was going to do pounds to kilograms, and I wanted to write out a unit map for this, what I would do is I would say something like this. I need to turn pounds into whatever. So I could do this. That's very straightforward because Google has a conversion for pounds to kilograms, and that's 1 kilogram equals 2.205 pounds, right? But I could also do this, pounds into grams into kilograms, where 1 pound is this conversion, and then 1 kilogram is 10 to the minus 3. And I would get the same answer regardless, because I started with pounds and I ended with kilograms, regardless of which conversion I use. And you'll notice that this conversion and this these are not the same, right? And yet when you do that, either way, you will get the correct answer. So, if you're looking at these and you're like, well, shit, I didn't think to do that. I went a different way. That's totally okay. You could do something like, I don't know, pounds to grams to, this is not exactly the problem that I should do for this example. But if I wanted to do, say, miles to kilometers, yeah, Google has a relationship for that. You could do that easily. But you could also do miles to feet, to inches, to centimeters, to meters, to kilometers. And regardless of which of these you pick, you'll get the same answer either way, as long as you have all the correct conversions. Obviously, the top one is preferable because there's only one conversion, and on the bottom we'd have to do 5. And so we would have, for this first problem, it would just look like this, where I have something, and my units cancel out. But down here, I'd have something that I started with, and then 1 conversion, 2 conversions, 3 conversion, 4 conversion, 5 conversions. And all my units would just cancel out like this. And then there would be kilometers at the end. So if you make a little like blueprint map to guide yourself from one unit to another, as long as you can find all the conversions for each step. So can I find miles to feet? Sure, 1 mile is 5,280 feet. Sure, I can look that up. Sure, 1 foot is 12 inches. And so on and so forth. If you can find all those conversions and then string them all together in a multiplication problem, you'll get the right answer. So let's look at a few problems that involve that. So here's our first one. How many hours are in 2 years? Now, you might be sitting there thinking, well, 24 times 30 times 12, or whatever, right? So let's make a map to try and link all of these together. When you convert cubic centimeters to milliliters, those are both exact. So they're both 1. So you can ignore the 1 rule there too. It's exact. A milliliter and a cubic centimeter are exactly the same thing. All right, so let's make a map for this to try and get to the answer. Now, if you don't know a conversion off the top of your head, or you aren't sure what to convert something to, just draw all of the possibilities, right? So I could turn years into months. I could also turn years into days. I don't know which of these is going to help me. I can turn months into... Uh-oh. Kind of hard when all the months are different lengths, right? So not super helpful that way. But days can be turned into hours. And that's what I want for my problem. So this is what I'm going to do. I'm going to turn years into days into hours. So let's set up our conversion. So here's the number that we are given, 2 years. And according to this, I want to turn years into days. So I have to figure out some number of years and some number of days. Well, if I look up on Google how many days are in a year, or if you just know that, 365 days in a year. What if it's leap year? Crap, forgot about leap year, right? Then it'd be 366. Well, leap year is every 4 years, so we'll just say there's an extra quarter of a day per year, which is actually true. You don't notice it because on the 365th day, we're just not quite to where we were last year at this time. It takes an extra quarter of a day to get there. It's still daytime when we get there, but that's fine. So now that I've turned years into days, this is how many days would be in a year if I hit equal right here. But I don't want days, I want hours. So I'm going to say days, hours. And how many hours are in a day? 24. And so I'm going to punch this all in the calculator. And I should get a ginormous number because this is a lot of hours, right? And so I got this. And so now the last thing we have to do is Sig Figs. So how many Sig Figs are in this? Well, it's 2.0, so that's 2 Sig Figs. This has so many Sig Figs. We can ignore a 1. We can ignore a 1. It turns out that this is exact, and the reason that that is exact is a definition. Anything that is defined, so like there's not approximately 24 hours in a day. There are exactly 24 hours in a day, because we said so. This is how we constructed clocks. You can ignore sig figs for that too. So really just measurements and stuff. So the smallest number of sig figs is going to be 2 sig figs. And so in 2.0 years, there would be, to 2 sig figs, 18,000 hours. All right. So my problem shows that right there. There's our map. Now, if you're confused about the, well, wait a second, why is 24 hours equals 1 day exact? What does that mean? I don't remember if there was a part back when we were talking about sig figs about exact or inexact numbers. Let me see if I can find that real quick. Do I have exact or inexact numbers in here? Yeah, here we go. So if I go way back to this slide right here, exact numbers that have no uncertainty mean that they're known exactly, right? You can think of an exact number as having infinite sig figs. And so this is why exact numbers like 1, exactly 1, or 24 hours in a day, they're exactly 24 hours in a day, don't affect your calculation for sig figs because they have infinite. They're exactly 24. They're 24.00000000 forever hours in one day, so it's exact. So that's why I've been doing that. So would we have 18 times 10 to the negative 3? Not negative 3. Positive 3. Down here I wrote 1.8 times 10 to the 4. You could do this with the dot over there. Those are the same number. Generally speaking, we have scientific notation has at least one, there's only one number before the decimal place. But engineering notation does write in powers of 3, so this is acceptable. I'm going to give you another one. Actually, I'm not going to give you this one to do. We're going to do this one together because this one's a little bit weird. Wait a second. No, it's not. I'm just confused. I was thinking of a different one. All right. I drive down the highway on my motorcycle when I had one at a constant speed of 75 miles an hour. How many minutes will it take me to drive 20 miles? Okay. And I want minutes here. So I'm going to let you play with this for like 2 or 3 minutes to see if you can get the right answer. I'll give you a hint. It should be less than an hour for me to get there. So go ahead and try this on your own. We'll go over the answer in about 3 minutes. And I'll show you how to do this problem. All right, let's go over the answer to this and see if we can find a logic to solving this problem, because it has a kind of a weird conversion in there. Like, I have a speed and a distance. How do I relate these two things together? Oops, I can't move that any farther up. There we go. So I want to look at this right here, first of all. 75 miles per hour. What that means is that I would drive 75 miles in 1 hour, right? Or in other words, if I know how many miles I can drive, I know how many hours it will take me to do that, right? So if I drove for 2 hours at that speed, I'd go twice 75, or 150. If I drove for half an hour, I would drive half of 75, or 37.5. If I drove 50 miles, that would be whatever fraction of 50 over 75 hours it would be, right? So I have a relationship between miles and hours. Well, since I want to know how many minutes it'll take me, I could just turn however many hours that is into minutes, right? And now I have a unit map. I start with the number of miles I drove, I turn that into hours, I turn that into minutes. So when you're given a conversion like this, what you're being given is a relationship that you can use to convert. Somebody is messaging me like crazy during the lecture. Let me turn the sound off here. It's the other class. Wes, we want to talk to you. Oh, they don't want to talk to me. They're talking to themselves. That's fine. Okay. So, how many miles did I drive? I drove 20 miles. And so I'm going to set up the unit so that they cancel. Cancel all my miles. Now I'm left with hours. How many miles and how many hours? Well, in 1 hour, you drive 75 miles, right? So we'll just fill that in. And then hours to minutes. How many minutes are in an hour? 1 hour is 60 minutes. And so I enter it all in my calculator. 20 times 60 over 75. It should take me 16 minutes at that speed to get 20 miles. Now we got to check for Sig Figs, of course. So this is 3 Sig Figs. 1 is exact, so we ignore it. 75, however, is only 2 Sig Figs. Do I drive exactly 75 miles an hour to the atom? No. There's no way, right? It might be 74.9 or 74.6 or whatever. 75 has to be rounded. These are exact because they're defined, right? That should be an ignore. There we go. I made that worse. Whatever. So my answer should have 2 Sig Figs, and it does. All right, there you go. All right, let's do some more complicated problems that have things like this in them. Like, this is a good conversion because making conversions between anything can be helpful. This is Scoots. Scoots is a puppy. He's not my puppy. I found him on the internet. I would adopt him, though, because look at that. Look how cute he is. Scoots loves kibble, as you can tell from his bowl. Scoots eats 65.3 grams of kibble every day. How many pounds of food will he have eaten in 35 weeks when he is no longer a puppy? We're going to assume that Scoots eats the same amount of kibble every day. because we don't want him to get fat. He already looks like he's round, don't you, Scoots? Oh. All right, so I'm going to let you try this for 3 minutes too and see if you can get started on it and come up with an answer in pounds for how much food he would eat in 35 weeks. So my advice to you to start the problem is, what's the conversion? How much what per what? And then what is the starting number? Work that out, and we'll go over the answers shortly. All right, hopefully you've got part of the problem done, if not all of the problem done. Oops, we can't capture Scoots in this because I need that space for the problem. All right, so let's write down, if I can find the pen, there it is. Let's write down what information we know. So we know that Scoots eats 65.3 grams per day. In other words, we know that he eats 65.3 grams in 1 day. So now I have a mass and a time. So I can relate those two things together. And I know that he has eaten for 35 weeks. So what I need to do is I need to turn this into days. And once I know the number of days, that will tell me how many grams he eats, because I know that he would eat that many days worth of food. And then I could turn grams into pounds, right? So my unit map's a little all over the place, but we could straighten that out. So I'm going to turn weeks into days. And then I'm going to turn days into grams and grams into pounds. So let's do the dimensional analysis. So I've got 35 weeks, which I'm going to abbreviate to that because I'll run out of space if I don't. How many days are in a week? 7. Okay. We'll cancel out our units for days and we'll turn it into grams. We're just following the blueprint here. How many grams does he eat per day? Well, that's up here, right? 65.3 grams per day. And then finally, we'll turn grams into pounds. And that conversion's on Google. So we know if you look on Google, that 1 pound, there are 453.6 grams. And there we go. If I punch all this into the calculator, I should get the number of pounds of food that Scoots would eat in that time. 35 times 7 times 65.3 divided by 453.6. And I get 35.270 pounds per week. Oops, not per week, sorry. 35.270 pounds in that time frame. Now, how many sig figs should I have? Is 35 weeks an exact number? Hard to say, really. As written, I think that it should imply that there are 2 sig figs. However, you could count weeks on a calendar, and then it would be exact. These are exact, so we'll ignore. This is 3 sig figs, and this is 4 sig figs. So my intent is that you should have 2 sig figs in your answer here. But if you ended up saying, well, this is exact, so I'm going to use 3 instead, then whether you wrote 35 or 35.2, I think I would accept either in this case. So Scoots eats roughly a pound of kibble per week, because he's a small puppy. We don't want him to get too big. If you don't feed him, he stays small. Please don't malnourish your pets. That is the worst thing. All right. Next problem for you. This is Hazel. Hazel injured her paw, and we're going to take her to the vet. And the vet recommended that the recommended dose of aspirin for a kitten is 3.67 milligrams per kilogram of kitten. How many milligrams of aspirin should be given to Hazel, who weighs 2.41 pounds because she is the most adorable kitten? Oh, Hazel. Now, this obviously is not my cat either. I found this on the internet, because if you type in cute cat pictures on the internet, it turns out you get a lot of cute cat pictures. But my cat, Hazel, was a calico kitten, which is what this is. And she lived to be 22, which is absurd for a cat. I adopted her when she was like 17 from a friend. And she lived with me for 5 years, and we could not believe how old she was. And she was spry and fit and happy to the very end. So, treat your cats right, and they'll treat you right. So, tell me how much aspirin I should administer to Hazel here, given that she weighs this much, and that's the dosage information. And then I'll answer that question in the chat. So, go ahead and get started on this, and we'll go over the answer in about 3 or so minutes. All right, once again, I hope you have gotten some progress on the problem. Maybe written out a unit map. Let's write out a unit map here for Hazel's. Medicine. I didn't clear the screen before I went back here. Normally I do that just to save time. All right, so I know that I can give 3.67 milligrams of aspirin. Not aspiring. Aspirin. Per, which is a division symbol, kilogram of cat weight. Or in other words, 3.67 milligrams of aspirin equals 1 kilogram of cat. So for every kilogram my cat weighs, I can safely give the cat that much aspirin. So this is where writing out all of your units becomes super important. Because notice that we have milligrams converting directly to kilograms. Normally you can't do that. And if you try to give a 1 kilogram cat 100,000 or a million milligrams of aspirin, because in a kilogram there are a million milligrams, you will overdose my cat and I will sue for malpractice. So don't do that. Use the relationship that is given in the problem and make sure that you are labeling your units carefully. Because if you just wrote milligrams to kilograms without context, it'd be confusing. Now, where does the weight of the cat come in? Well, the cat's weight was measured in pounds, right? So if I know how many pounds my cat is, I can look up the conversion between pounds and kilograms and do that. So that's what we're going to do down here. So I'm going to start with my pounds, which was 2.41 pounds. And we're going to turn that into kilograms of cat. And we're going to turn that into milligrams of aspirin. We're just following our little path that we made up above, right? Now, if I wanted to be extra clear, I could say pounds of cat and kilograms of cat. And then we look up the conversion from kilograms to pounds. 1 kilogram is 2.205 pounds, according to Google. And then what's the dosage information for this? Kilograms of cat, milligrams of aspirin. We're going to cancel the cat. Oh no. And according to this, for every 1 kilogram of cat we have, which is this up here, we would administer 3.67 milligrams of aspirin. So how many milligrams of aspirin do I give to Hazel? 2.41 times 3.67 divided by 2.205. And the answer I get is 4.0112 milligrams of aspirin on my calculator. There's more digits, I just stopped. We're going to ignore all the ones for Sig Figs, just like we've been doing. This number is 3 Sig Figs. This has 4. And this has 3. This one right here. 3 is the smallest, so my answer should have 3 Sig Figs. And there you go. So give her a 4 milligram tablet, grind it up really quick, put it in her wet food, and she should be okay. Or open her mouth and pill her. Give her a pill and force her to swallow it. If you've ever had to give your cats pills, it is obnoxious and sad, and I hate doing it. Fortunately, Maya and Kresnik are in good health, and I don't have to worry about that too much. All right. I have a set of 3 problems here that I do want you to try. However, before the class ends in 10 minutes... Oh, also, here's the homework practice. Oops, didn't circle. For the textbook. So I want you to try these on your own. We'll go over the answers to those tomorrow. Somebody wanted me to do questions with temperature. The next section is actually on density. I'm going to skip that. Oops, that's the wrong button. We're going to do density tomorrow. That's also the wrong button. That's the right button. And we'll do a little bit of temperature here because I know that is on your worksheet. That is due Wednesday. So just real quick, we'll talk about temperature. Here are the 3 units that we use: Fahrenheit, Celsius, and Kelvin. Fahrenheit is dumb. It is used to confuse Canadians. My buddy Mike, who lives in Ottawa, and I talk about the weather all the time because that's what we do. And he says, yeah, it was so cold today. It was like 2 Celsius. And I'm like, wow, it's been unseasonably warm for winter. It was 55 today. And he goes, holy crap, 55? Because he's thinking in Celsius. 55 in Celsius is really hot. The hottest places on Earth don't even reach 55 Celsius. Maybe just barely. But I wanted to say, no, it's actually like below room temperature, 55. So Fahrenheit confuses Canadians. That's its use. We use it in America, and it's dumb. Celsius is used in the laboratory for a specific reason that we're going to talk about on the next slide. No, we're not. That's okay. And then Kelvin is used in calculations that we're going to talk about much later when we get on to gas laws. So Celsius and Kelvin are very similar. We'll just use that for now. And then Fahrenheit is its own thing. How do we convert between the 3 of these things? Here are the formulas that we use. There are 2 formulas here. And everything in these problems for Fahrenheit and Celsius is exact. Okay? So 1.8 is an exact number, and the 32 is an exact number. When we do Celsius and Kelvin, though, this is inexact. And depending on the process that you are doing, you may or may not need this many Sig Figs. If you need more, this does keep going. There are other numbers that come after this. So if you do Celsius plus 273, since it's inexact, as written, if we were doing 3 Sig Figs, you would round your answer to the ones place. If you wanted to round to the 10th place instead, you'd use this 0.1. Hundredths, you use the 4, and so on and so forth. Okay? So let's do an example of both of these problems. You could read about absolute zero. We'll talk about that later. It's not super important. Absolute zero is related to temperature. In fact, it is how we define Kelvin. We'll talk about that when we get to the kinetic theory of matter in Chapter 7. Just remind me. So I'm going to do these first 2 as an example. And then you'll have seen how to do these, so you can do them for your lab. So it'll be okay. And then you can do the other conversions on your own time. So let's start with the first one, 175 Kelvin to Celsius. And so our formula is whatever our temperature is in Kelvin is Celsius plus 273.145 or whatever. How many Celsius? It's on the screen right now. Remember, you can pause the video if you need to. So if I do algebra and I want to solve for Celsius, I could do something like this. Kelvin minus that number equals Celsius. So let's do that subtraction problem. 175 minus 273.145. Now, if you are doing subtraction and you have you're subtracting a bigger number from a smaller number, here's the way that I do this. I flip the 2, and then my answer will be negative, and I just do the subtraction like normal. Alternatively, you could just punch it in your calculator, but I do want to show you this for purposes of Sig Figs. So if I do this, I would get 145. 13 minus 5 is 8. I get something like this, right? And then what we're going to do is we're going to round to the correct number of sig figs. Well, there's nothing here or here or here, so I don't get these digits. I would instead round to the ones place. So I would say that 175 Kelvin is negative 98 Celsius. And then we'd have to tack the units on there too. And that would be good to the ones place because of how addition and subtraction rules work. Okay, so be mindful of that. Whatever number you're starting with is going to dictate your sig figs, right? But it also depends on what operation you're doing. So here, when you're doing these formulas, you're going to be doing a bunch of addition and subtraction. So just beware. All right, let's do the next problem, and then we're going to be out of time for the day. 47 degrees Celsius to Fahrenheit. Now, what is the formula for Celsius to Fahrenheit? So you can use either formula, but because we're going to Fahrenheit, I'm going to pick the one that is already solved for Fahrenheit. So that is, and I always forget this, so I'm just looking it up. Whatever your temperature is in Celsius times 1.8. And then we're going to add 32 to it. And remember, these are exact numbers, these both. So I'm going to plug this number right in where it says Celsius. And so my temperature in degrees Fahrenheit is going to be 47 times 1.8 plus 32. And this number has 2 sig figs, but the other ones are exact, like we said before. So let's look at that. So let's do the problem. 47 times 1.8, according to the calculator, is 84.6. I can only report 2 sig figs, so in my parentheses, that's going to become 85. That should be a 5. I just messed up with my pen there. 85. And then I'm going to add 32 to that. Now, if I set that up vertically, 85 and 32. 32 is exact, remember? So it's technically just me adding this forever. So it's not going to affect my sig figs, but the 85 is. We're going to round to the ones place. And there's our answer. And our answer goes to the ones place. And it does have 3 sig figs because the last step that we did was addition. So be mindful of that. Don't just automatically say for every formula problem you're going to count the number of sig figs the first number has. Because addition and subtraction will mess that up, okay? So be careful. This is why when I say, oh, it's 55 today, my buddy in Canada freaks out because 55 would be even hotter than 117 Fahrenheit. You don't go outside when it's 117 Fahrenheit. You stay indoors where it's air conditioned because you could get heat stroke very quickly and perish, basically. So we don't want that. No perishing in my class. All right, so those are some examples of how you do temperature problems. So apply that knowledge to the worksheet and you'll be in good shape. So when we come back on Wednesday for tomorrow's lecture, you could do the rest of these problems on your own. I think there's a homework practice on here. Yeah, there we go. I just didn't go far enough. So we skipped over section 2.9, which was density. We're going to do the density problems there, which is right here. This is where we want to be. So I'm going to put this on the screen just so it bookmarks it. That'll be the end of chapter 2. We don't do the heat section in my slides. That was from an old version of the textbook that it's no longer even in the modern version of the textbook. I don't know why they took it out, but we don't do it anymore. So those slides are just sort of there. And I am going to ignore them, and you can too. So I do want to thank everyone for coming out to the lecture. Make sure that you get quiz number 1 in tonight. That is, again, on chapter 1. The quiz for chapter 2 will be posted tomorrow, because that's when we finish chapter 2. Chapter 3 is rather short, so there may also be a chapter 3 quiz going up tomorrow as well. So, thanks again for coming out to the lecture. Let me know if you have any questions in the Discord. We've been answering them all week, so put them in there. Take care, and I'll see you tomorrow.